Okay, here in example 4, we're going to write an equation for the nth term in a sequence. So we have two examples, example A and example B, where we're given kind of different information. In example A, we're given first 4 terms in a certain sequence. Example B, we're given the 8th term and the common ratio. Either way, we'll just apply this by filling in our explicit formula down here that says a sub n equals a sub 1 times r to the n minus 1 power. Okay, remember that what this thing is telling us is that any number in the sequence, so like let's say we want to get the 5th number, for example. The 5th number is going to be the first one times the common ratio 4 times, right? Because if we start at the first one and we want to get to the 5th position, we need to take 1, 2, 3, 4 steps to get there. We need to do 4 rounds of multiplication. So it's always n minus 1 rounds of multiplication to get to the nth term. Okay, well, we need to figure out what the common ratio is, so we can take any two consecutive numbers, like the 3rd term and the 2nd term. We could use the 4th and the 3rd, or the 2nd and the 1st. As long as they're consecutive, we can get the common ratio. So in this one, it would be -3 that we're multiplying by each time. So that'll go in for position R, like in the purple here. We put in our first term in the front, and there we go, we have it. Now, we're not going to combine these two negatives. If you think about that, if you combine the two negatives, you get a positive number, and then you'd be doing exponents with a positive base. You'd be multiplying by some positive number repeatedly. That's not what we're doing, though, right? We're multiplying by a negative number repeatedly. So we need this negative number to be the only thing that this exponent is applied to. We keep those negatives separate, and that's all there is for that one. For B, they've told us that we've got A8 is 5 and R is 1/2. So we can fill in the R of 1/2 in the equation. We can put in our 8 up here for n because we've been given information about the 8th term, and we can put in a 5 over here for the actual value of that 8th term, right? A sub 8, which is what we're looking for, would be what would go in right here. So that would be that 5. So the 5th term is the first term times 1/2 taken 7 times, 7 steps of 1/2. So 5 equals A1 times 1/2 to the 7th. Okay. Simplifying the exponent, we have just 7 here rather than 8 minus 1. And evaluating the exponent, well, 1/2 to the 7th power. I'm not exactly sure what that number is going to be. Let me see. 1/2 to the 7th power. So 0.5 to the 7th is 0.0078. Okay, so 0.0078 is going to be what's going to go into this little box, or into this parentheses here, which means that to get A1, we would just have to divide both numbers by that coefficient of 0.007. So we'll do 5 divided by this. $640. So 640 would be our first term. We must have had 640. We multiplied it by 1/2 over and over, and eventually got down to 5. Okay, writing out that equation, we'd say 640 is our first term, and our common ratio is 1/2. Therefore, our formula is a sub n equals 640 times 1/2 to the n minus 1 power.